So hey everyone, this is Code Runner, and in this video I'm going to explain this question, that is evolute reverse polish notion. So we have given this strings, that is tokens, and these that represent an arithmetic operation in the reverse polish notion. So we have to evolute the expression. So we have to return the integer that returns the value of the expression. For example, the valid operators are plus, minus, multiply and divide, and each operand may be an integer or another expression, and the division between two integer will be always truncates towards 0. Okay. The integer will be 2, there will be will not be any divisible by 0. Okay. The input represent a valid arithmetic expression in the reverse polish notion, and all the intermediate calculation can be represented in 32-bit. For example, let us understand this question with the help of this test case. So I have given this input, that is I have given a token array, and we have given output. So what we have to do is simply, for example, here this is 2, this is 1, so we need to we can say we need to apply this operator upon these two integers. For example, in this case 2 plus, that is 2 plus 1, that is 3. Now the our array array become, that is 3 and this multiply sign. So now what we have to do is simply we have to we can say evaluate this expression on the basis of the next operator, that is multiplication. So 3 into 3, that is 9. So 9 is our, we can say, desired output. So what we have to do, we have to simply look the numbers in the array, and we can evaluate the expression on the base the numbers on the basis of these operators, that is plus, minus. We can say we have to simply solve these we can say uh, accumulate these integers on the basis of their adjacent operators. So let's understand with the help of another test case. So for example, if I take another test case, that is if I take this test case, that is this. So let me clear this. So for example, so in this we have given 4, 13. So 4, 13 and 5. So now what we have to do, we have to simply we can say perform a division between 13 and 5, that is 13 divided by 5, that is we can say 2. So our this 13 divided by 5 is 2. So our we can say our output of this expression will be 2. Now we have to perform the we can say addition operation between these two operators. Then 4 plus 2, that is 6. So this is our desired output, it is 6. This is 6. So what we are doing here is simply, you have noticed that simply what we are doing here is simply we are looking for the first of all first of all we have numbers, and then we have operators. So we have to evaluate these numbers on the basis of these these operators. For example, if there are 13 and 5, then I have to take the two, because operation will be occurred between any two operands. So I have to take the adjacent two operators adjacent to the operator. For example, in this case, we have this division sign, and we have this operands that are 13 and 15 adjacent to it. So we need to perform the division operation between these two, 13 and 15, that is 2. Now our array will be 4 2, and the plus sign will be remaining. So now we have to perform this addition task between these two operands. Okay, so one thing you have noticed here is we are performing the operation between any two operands. So this is basic thinking, basic logic. If we we are simply we have to simply evaluate, we can say, perform any operation, we can say any expression, or we can say from any task that is multiply division between any two operands. So we need any two operands. So first we will evaluate this, and we will calculate the result for this operation. Then we will move to the next element. So in this 4 plus 6 4 sorry 4 plus 2 is, that is 6. So 6 will be our answer. So here simply what we are doing here is we are given the string, so we need to convert it into the numbers. For example, if I have this 4, so I have to convert this into this 4, that is integer. So in C++, there is and we can say keyword. With the help of this, we can simply convert it into the string. So sorry, string to the integer, that is string to integer, that is stroi. This is a keyword. With the help of this, if we put this 4 string into it, then it will give the, that is 4. So we will took the help of here, we can see that we have to compare this addition element. So here we will took the use of, that is stack. We will make use of stack. What we will do, if we encounter any numbers, we will iterate. First thing we will do is we will iterate through the array, and we will if we encounter any number, let's say this is 4, so we will put this 4 inside our stack. That is our stack become, that is 4. Now we will see this 13 is our number, so we can say integer. So this will be also inserted inside that is stack. Now 5 will be also in, because it is integer, so 5 will be also we can say put inside the stack. So now if we encounter any operator, then what we have to do, we have to simply we have to we can say pop these elements from the stack and put it into the variables. For example, let's say this 5 will I will store this 5 into variable 5, sorry y, that is 5, and this x into this 13 will be into will be stored into the this x. So now if uh, we have finded the two operands, then we need to perform the we can say task, that is the given, if given operator is division, then we have to perform a division task between them. For example, in this case, so 13, that is x divided by y, then this task need to be performed, that is 13 divided by 5, that is 2. So this is 2. So our stack will be only carry only 4. So this 2 will be come, and then we will do, then what we will do, put this 2 into the stack, then we encounter another operator, that is plus operator, that is addition operator, sorry, that is addition operator, and then we need to perform the we can say addition between these two operators, that is 2 plus 4, that is 6. So our desired output is 6. So we took the help of this stack. So simple logic behind this is, if we encounter any, we can say, because we are using stack, because as we know, we have to make the operation between adjacent element. Okay, we need to we can say we need to perform the operation between any adjacent element, and resultant of these two operator these two operands, we need to the result of these two expression, we need to perform the operation with the this next element. So there will be because this stack run on the principle, that is stack uses the principle, that is LIFO, that is last in first out, principle. So if we insert this into the stack, so the the first element will be at last place. So and resultant of these expression will evaluate and will be calculated by performing these operations, and at the last we need to perform the operation between the top element, that is 4, and the rest of the expression, answer of the rest of the operation. So that's why I have taken the help of the stack. So let's see the code for better understanding. So what will I do? I will simply iterate over the string, that is tokens dot, you can say tokens dot, token is vector na, okay, tokens dot size is I plus plus, and I have to take one stack, that is, let's say this is stack S. So simply I will write the condition. I will write the condition, this if our token of I, simply I will write this condition. Simply here I will replace the A with the tokens. This is tokens So the first operation is here is simply I am checking that if the encounter index is number or the expression. If they are expression, so we need to perform the operation between them. If they are numbers, simply we have to push the numbers into the stack. So this is the first thing I noticed. Then after that, if I encounter the we can say operator, then I have taken the first two element of the stack and perform this operation, that is division, addition and multiplication. So and we are simply pushing the resultant of these two operands, we can say these two operands into the push back into the stack. So and we will at the end the resultant of this operation will be at top of the stack, and we need to simply return that. So this will be the current we can say correct approach for this. And we can say what with the time complexity. So let's just get the time complexity for this. So time complexity will be, as we are iterating the we can say array at only at once, so the time complexity will be simply big O of n. Here n is the size of an array, that is tokens dot size. This is tokens dot size. Tokens dot size. Okay. Now next what we have to do, that is space complexity. So space complexity will be also, that is constant space complexity, because at the end what we are getting is simply at the top of the we can say stack only one element will be remaining na, only the resultant element will be remaining. So as we are taking the stack, as we are taking the extra auxiliary space, so big O of n will be the, we can say, yeah, big O of n will be the space complexity for this question. So thank you for watching this question. So I hope you will get this logic, and yeah, that's all this question. Thank you for watching.